So our first question is from a November 2019 exam. So if you notice, there's quite a bit going on in this particular question. So we've got an inclined plane, and the force that's acting on object Q is also inclined. In addition to that, if you notice between A to B, there's friction, so it's a rough surface. Whereas I'm assuming between B to C, because they've taken the time to indicate the difference in the surface, I'm assuming between B to C is smooth, as you can see there. In addition to that, we've got tension in here as well. So there's quite a lot going on. Now, question 2 reads as follows. Block P, so here's block P, let's color code it, so it makes things a bit easier for us to identify the different information. So that's block P of mass 2 kgs is connected to block Q. So we have this block Q of mass 3 kgs by a light inextensible string. Both blocks are on a plane inclined at an angle of 30 degrees to the horizontal. So this information is also important. Block Q is pulled by a constant force of 40 newtons. So this is the applied force on block Q at an angle of 25 degrees. So be careful, don't mix up the two angles. Block P moves on a rough section. So that means there is friction for block P on the off the incline, while block Q moves on a frictionless surface. That means there's no frictional force acting on block Q. BC of the incline, see the diagram below. Okay, before we continue, do you have any questions?
No, I think I'm good so far.
Okay. Then they state that there's an average frictional force that is acting on block P, and that magnitude is 2.5 newtons. Now, our first question is to state Newton's law or second law of motion. Do you remember Newton's second law of motion?
Yes.
What is Newton's second law of motion?
When a resultant force acts on an object, the object will accelerate in the direction of the resultant force. The acceleration is directly proportional to the net force and inversely proportional to the mass of the object.
That is correct. So let's move on to 2.2, right? So for question 2.2, it states, draw a labeled free body diagram of block P. So let's discuss block P, right? So if we look at block P, there's about 4 forces that are acting on that block. An indication of that is because the mark allocation is 4. You get 1 mark per block, per force, sorry. So what are the 4 forces that are acting on block P?
It's normal force, gravitational force, frictional force, and applied force.
There's no applied force. Remember, we're looking at this one. Applied force is this one.
Is it tension?
Yes. So which direction is frictional force acting and which direction is tension acting?
Tension is acting in the direction to block Q, and then frictional force is acting in the opposite.
That is correct. So from here, we'll just draw a dot to indicate our mass. Then we've got tensional force acting up the string. We've got frictional force acting in the opposite direction to motion. We've got Fg, or gravitational force, acting straight down. And we have normal force that is always perpendicular to the surface. So those are our 4 forces. From here, let us look at 2.3. Now, 2.3 states, calculate the magnitude of the acceleration block P while block P is moving on section AB. So we need to calculate the acceleration of block P while it is moving between A to B. So what we're now going to do is we're going to break this up into our force components, right? So let's have a look at our free body diagram while we do that. So we have F net is equal to mass times acceleration, right? From here, what are we going to break up F net into?
For block P, right?
Yes, for block P.
Okay. It's going to be tension.
Yes.
Minus frictional force.
Yes. There's one more.
Minus gravitational. Yes, minus gravitational force.
Will it be Fg parallel or Fg perpendicular? Or Fg itself?
Perpendicular.
Will actually be the parallel component. So remember, perpendicular moves like this in the vertical direction. Then parallel will move like this in the horizontal direction. You can also draw parallel here if it's easier for you.
Okay.
So you can see that it's in the horizontal direction. And this angle here, what would that angle be in this particular area?
Will it be the 30 degrees?
That is correct. So we'd have 30 degrees over here. Now from here, this is equal to mass times acceleration. Now we know that tension is unknown minus Fk. Now what is our value of Fk?
2.5.
That is correct. So in place of Fk, we substitute 2,5 minus, we need to find the formula for Fg parallel. What would our formula for Fg parallel be?
Mg sine theta.
That is correct. Mg sine of theta, in this case it would be 30 degrees. So we're going to substitute mass, which is 2 kgs, times g, which is 9,8, times sine of 30 degrees is equal to the mass, which is 2, times acceleration. Now keep in mind, we were told to calculate for acceleration, right? Now, if you notice, we have 2 unknowns. So what is going to be the method that we are going to make use of to solve for this particular question?
Simultaneous equations.
That is correct. The reason is because acceleration of both blocks will be equal and the tension of both blocks will also be equal. So we can use that to use or make use of simultaneous equations. So, okay, just give me a second. So this is going to be minus 2.5 minus 2 times 9.8 times sine of 30 degrees. That gives me minus 12.3. So from here we have tension minus 12,3 equals 2a. Now, if we are solving for acceleration, what are we going to make the subject of our formula? Is it going to be t or a? Remember, we discussed it the last time.
A. No, T.
That is correct. Whatever you're solving for, you make the other one the subject of your formula, so that when you connect the subject, okay, it's going to be tension equals 2a plus 12 comma 3. This is equation 1. So what do we do from here?
I'm thinking we break down the components for block Q.
Yes. And if we look at block Q, what forces do we have acting on block Q?
We have tension, applied force, gravitational force, and
Yes, tensional force, gravitational force, and
applied.
yes. One more.
Normal force.
That is correct. So block Q, so we have tension that's acting down the slope. We have Fg that's acting straight down. We have normal force. We have applied force that's acting at an angle. And then let us include Fg perpendicular. And Fg parallel. This will be 90 degrees. This will be 30 degrees. Let us also include the components of A. So here we'll have FA in the X direction and FA in the Y direction. Now let us find FAX and FG parallel. So let's start with FG parallel, since that's something we're used to getting. How would we find FG parallel?
FG parallel would be mg sine theta.
That is correct. And remember, this applied force is 14 newtons, right? So what would FAX be?
Mg.
Not mg, it will be applied force cos theta. So applied force is 40 cos of 25. Remember, this part in front is the resultant force. For here, the resultant force is applied. Here, the resultant force is Fg. So just be careful with that one, okay? Then we break it up into F net. From here, what am I going to break F net up into?
It's going to be are we going to use, oh yes, it's going to be
All the horizontal. You were saying?
It's going to be minus t
Yes.
minus mg sine theta.
Remember, mg sine theta is fg. It's just duplicating.
Yes.
Okay, let's do this. What forces are acting in the horizontal direction? Give me a list of them.
It's FG and
Which one? FG parallel, perpendicular, or FG itself?
FG parallel.
Yes. Then
We have also FAY. No, FAX.
yes.
And then
There's one. Everything that's moving in the horizontal direction, which will be everything that's along this line. What about tension?
it's also tension.
So we can see everything moving along this line is FG parallel, tension, and FAX. So we have to include all three of them. So which one's a positive between tension, FAX, and FG parallel?
FAX is positive, the rest are negative.
Perfect. Now we need to substitute. So FAX we know is 40 cos of 25 minus tension minus FG parallel is mg sine of 30 equals mass, which I think is 3. Yeah, 3 kgs. 3 times acceleration. From here, we can substitute mg. So let's do 3 times 9.8. So that is going to give us, let's see, 40 cos 25 minus 3 times 9.8 times sine of 30. That gives me 21.55 minus 3a equals tension. So all I did was take tension to the right so that I can make it the subject of my formula because it was negative on the left. So that is question, or rather equation 2. Are you okay with what we've done so far?
Yes.
Now we're going to equate the two equations, right? So we'll have equation 1 equals equation 2. So we know that equation 2 is 21,55 minus 3a, and then equation 1 is 2a plus 12.3. So from here, we need to solve for a. So if we take negative 3a to the right, it's going to be positive. So we'll end up with 5a equals, then if we take that 21.55, if we take the 12.3 to the right, it's going to be minus. So we'll have 21.55 minus 12.3. That gives me 9.25. From here, we'll divide by 5 on both sides. That gives me 1,85. Are you okay with that?
Yes.
Perfect. So I think that was 2.3. We've got one last one. Do you want us to also show how to find tension?
why not?
So tension, all we do is we can take one of the other equations. It doesn't matter which. You'll get the same answer irrespective. So we know that our tension equation is equal to 21,55 minus 3a. From here we substitute a, so we have tension equals 21,55 minus 3 times 1,85. So 21.55 minus 3 times 1.85. That gives me 16. So tension is equal to 16. And what's the unit of measurement of tension?
I do not know.
Remember, tension is a force. So its unit of measurement is newtons. So Fg, tension, applied force, normal force, frictional force, those are all forces. So they get newtons as their unit of measurement. Now we have question 2.4. If block P has now passed point B, how will its acceleration compare to that calculated in 2.3? Choose from greater than, smaller than, or equal to. So they're saying that block P has now passed point B. So block P is now here in the no friction area. Okay, so this is where block P is now. And they want to know how will the acceleration compare to that calculated in 2.3. So they want to know, will the acceleration, remember we calculated acceleration to be 1,85. So once P passes point B and moves in this no friction area, is the acceleration going to be greater than 1.85, smaller than 1.85, or equal to?
Equal to.
Think about it like this. If you are running on a surface with shoes, think about that. Then if you run on the same surface but there's oil on it, where would you move faster?
With the oil.
Yes. So wouldn't your acceleration now, because even though the acceleration of P is equal to the acceleration of Q, but remember, the acceleration of Q, or the acceleration of the system, is slowed down or reduced because of the friction. Once both blocks are on an area where there's no friction, the acceleration of both blocks would increase because the applied force increases, or you could say because both are on a smooth surface, or you could say because the frictional force decreases, which means that the acceleration would increase because there's no longer that force that's pulling it down. Before there was a frictional force in the system. Now the frictional force has been removed. Does it make sense?
Mm-hmm.
So now in this case, because both blocks are on a smooth surface, both blocks would move faster. Whereas before, one was on smooth, one was on friction. So here we could say 2.4 is going to be greater than and you could state because applied force increases, or you could even say because frictional force decreases, becomes 0, or there's no frictional force. Okay, so that is from a November 2019